The last type of graphs that we have are called Hamiltonian circuits and paths. And so this is named after a mathematician named William Hamilton. And what he did was he looked to see, so Euler did edges, okay, but Hamilton does vertices. So if it's a Hamiltonian circuit, if you can go to each vertex exactly once and then end back at the same vertex. It is a Hamiltonian path if you can go to each vertex exactly once, but you end at a different vertex. All right, so the way I kind of think of that one, I do like the alliteration. So Euler edges, I think of Hamilton Halloween. Think of the vertices as the houses. You go to each house exactly once on Halloween night. All right, so for these, let's see which of these graphs we have that are Hamilton paths and which ones are Hamilton circuits, if they can get classified as either way. Maybe they can't as either one. So for this first graph, it doesn't matter which vertex I start off with, it's just going to be trial and error. So the nice thing about Euler is that he had a method. You look at the degrees. For Hamilton, you really just have to do trial and error. So for this first graph, I could go from this house or this vertex to this one. I can go to this one, I can go over here, and then I can go back to where I started. All right, so this one would be a Hamiltonian circuit. For this graph, again, I just pick a vertex and I just have to do this by trial and error. And I'm going to be able to go to each vertex exactly once and then start and end in the same place. So once again, a Hamiltonian circuit. This one might take a little bit more to think about. Let's see what I can do. Now I got myself stuck because I can't go back to the same house that I've been to or the same vertex until I've gone to all of the other ones. So if I try that one again, starting somewhere else, same issue arises. So this one right here can't be classified as either a Hamiltonian circuit or a Hamiltonian path. All right, this graph, once again, it's a Hamiltonian circuit. For this graph, that's not going to work. Let me try with something else. What if instead I try this? Again, you can't see it, but there is an edge right here. Okay, now I did not start and end in the same place, but I did get to go to every vertex. So this would be a Hamiltonian path. For this one, again, just trial and error. Okay. I can't go back to where I started, but I did go to each vertex exactly once. So once again, this is a Hamiltonian path. And then for the last one, started and ended in the same place. Each vertex I went to exactly once. This, once again, is a Hamiltonian circuit. All right, so Hamiltonian, you have to just do trial and error. Okay, circuit means you can start and end in the same place. Path means you start and end in different places. Euler, look at the degrees of each of the vertices. If it's all even vertices, then you have an Euler circuit. If there are exactly two odd vertices, you have an Euler path. And if you have more than two odd vertices, you don't have anything. All right, thanks for watching. Your homework is posted on mathexcel4school.com.